Hi everyone, this is Raju from Smart AI Technologies. Today we will be working on a concept called crop recommendation system using machine learning. So here we will see three concepts. One is what is crop recommendation system and why we need it and how we are going to implement it. In the third part it will be entirely a coding thing. So here we will use Python to build and to analyze the data that we have, and in the end we will build multiple machine learning models. We will compare their accuracies and we will test it on some data. It will be exactly like this. You can see here, once I build a model, I will feed some input to it and I will get the prediction done. So it is predicting that for particular feature, like if n is 36, p is 125, k is 196, temperature is 37, humidity is 80.65, pH is 6.15, and rainfall is 66.83. If these conditions are there, in that condition the best crop you can grow is grapes. That is given by my machine learning model, but the result is grapes. So here you can see the result is matching. It means this is the result, this is a prediction done by my model. They both are same. It means our model is working fine. If you want to analyze in the manner of accuracy and classification report result, you can see here I made like this for all the different models that we will see in depth while we work with coding part. So before that we will see two concepts. First of all, what is crop recommendation? So in this step what we want to do is, for example, there is a land, okay, here this soil is containing particular amount of nitrogen N, P and K, potassium and phosphorus, okay, potassium K, phosphorus P, and there is a particular rainfall, amount of rainfall will happen, okay, and the temperature is a particular temperature is available. So these features are there. Now you can't grow different type of crops here. This whatever the thing you can see, maybe graphical or maybe temperature and rainfall, whatever you see, these features affect the crop you grow. So in this situation, what if you are able to decide which crop to grow and which will be successful in this situation? So farmer will get profit, okay, there will be no word for loss. In normal case, people or farmers will not be that much well know about all these features, but in present days India is getting well developed in even in agriculture field also, but there are few people who don't worry about these things. They will decide which crop to grow based on the previous year which they grew, like maybe for example from 20 to 30 years past what they are growing and how much yield that soil is giving. Based on that they will decide, okay, I will go with this crop, I will go with particular crop or like that. But what if a farmer is able to decide based on what is available with him, maybe rainfall matter, maybe water availability, or what is the NPK of his soil, temperature, okay, once he can decide based on this feature, there will be no chance for losses. Okay, our main aim is to solve this problem. Okay, this is a crop recommendation system. It means based on the features or available parameters we should decide, okay, our machine learning model should recommend a farmer, okay, or help him to decide which crop to take. Why we need it? Our first case is reduce loss. This is most important parameter. Nowadays in Indian agriculture we are going into a big loss, so many productions are going into losses, and you may heard like many farmers are getting like they are suiciding because of the losses. This we should take it very seriously, okay. So we need to come out with some particular or some very particular solutions, okay. As we are machine learning people and data science people, what we can do, what we can try to do so that we can solve this problem or we can reduce this problem, okay. And okay, first why we need to take care is because to reduce the loss, that is a one condition, and here to help farmer with not only reducing loss, with saving his time. So I will tell you why I am saying telling this saving time. Okay, in this one, in the particular field, farmer will grow one crop, okay, without knowing the features, and he will just decide based on the history, and he will grow one crop, and after that he will grow another crop, okay, because he may fail in the first crop because he decided based on the history, but few things changed with the time, okay, maybe soil quality reduced, okay. That will happen normally. Why? Because nowadays so many pesticides and all those things are there, using them continuously in the soil will uh, make our soil worthless, so that will happen. So the farmer blindly selected based on the history that particular crop he want to grow, but he didn't think about what is happening to soil, okay. So soil may lose some features and it may not work well to this old crop going, then he will decide to go with another blindly again. So there you will be getting continuously deviated from the reality. So save the time, okay. Above one was save the time, saving the save is money, that is last nothing but money, and save is time. These both things are much crucial for any farmer. So then comes how. As I mentioned, in the how part we will be taking the coding, so we will let us move with the coding one. Before moving to coding part, let me show you the data set what I have. So this is a data set that we have. So it contains what is the NPK parameters, and temperature and humidity, and what is the pH of soil, and what is the range of rainfall is happening on that area. So based on that, we can decide which crop to grow. You can see here. So how many rows of data we have? We have nearly say 2201 type of data available with us. So this is our data set. Now how we will work with our coding part. First I am going to import all the libraries that required. So first I will import pandas, which is used to import the dataset, numpy, which is used to work with arrays, multidimensional arrays or arrays. Then I am going to use matplotlib, which is used to plot the graphs. Seaborn, this library is used to plot the graphs, okay. This warning is used to suppress the warning. You don't need to import this if you don't want, okay, that's fine. Without using this also it works fine. So then I am going to import my dataset using pandas, that is crop recommendation.csv. Once I call that using a pandas function called read underscore csv, data will be my variable. This we call it as a data frame. So data frame just looks like a row and column stuff, that what you can see in your Excel sheet, just like that, okay. Now I am going to print top 5 values, that is data.head.invert. From data whatever we have, just print out top 5 values so that I can visualize how is my data set. If you want to print out from bottom, you should give tail. If you give 5 you will get 5 values, if you give 10 you will get 10 values from bottom. And then comes, you just need to check what is data set, what this data set give us. So first thing is number of rows, that is 2200, and another one is columns. What are the number of columns are there? 8 columns are there with us. So if you want to check what are the names of those columns, that you can print it using data.columns, okay. Now you need to check for the duplicates first. If there are any duplicates, we don't have any duplicates in our data set. If we have that duplicates, just drop those duplicates. Having so many number of duplicates doesn't mean anything, it's just a repetition of same variable, same thing, okay. So duplicates will remove that if available. Then we'll check for seasonal.sum. What this seasonal.sum will give us, it will give us is there any null values in our column. What is mean by null values? Okay, so here you can see if my data is this, let me give you a clear concept. Okay, if this data is missing, say pH 6.50 is missing, that means this pH column is having one null value, that is the empty value within the data. So we should not have any empty values, because all these machine learning and deep learning models are a set of equations, so you don't need to have any empty values. If you have any empty values, you can't apply machine learning models over that particular data set. So we need to check it. What if we add any null values? What we should do? In that case, we will be having so many options. The first option is remove the entire row itself. In which row there is empty cell, remove that entire row. If you don't want to remove, there are two options. Either you can go with mean. It means you take one column, you take mean value of that column and replace the empty spaces. Median also same. If there is a column, few values are missing, then we will take median of that column and we will replace those empty values with median, like that. Okay, now again I am going to check basic information about my data set. It will give me what are the number of rows are there, what are the number of columns are there, 8 columns. Again it will give me which column is containing what type of data. N is containing integers, temperature and humidity containing float values, but in the end label is containing object types. Okay, so let us move to data.describe. What this description will give? For example, n, in case of n, it will give us count, nothing but count will give what are the total number of rows are there. Mean nothing but it will give me what is the mean value of n from our data set. If you go to that n column, you take all the values and divide by total number of values, you will get mean value. That will be okay, 50 is mean value. The standard deviation, which is calculated, standard deviation is equation, will calculate that on that particular column. Okay, what is the minimum? What is the minimum value of n that particular data set is having? It's 0. It means there is a location, in which location there is a soil which containing 0 n. So 25% of our data, it means if I have 2200 location soil data, among them 25% of soil samples are containing 21 n, okay, 21 n, and 50% of my data is 37. 75% of my data contains 84 n, and at max there is a soil which contains 140 n. So like this you can analyze all these features one by one. So again I am going to check what are the unique values are there. When I see n, what is the unique value? It means 1, 2, 3, 20 n, 50 n values. Like one n value which is repeated multiple times, that is 137 different kind of things are there. So again k, p. So when you check label, it says 22. What this means? Our label is a crop name. So totally when I do unique, it means it will give me what are the different type of crops are there. It means I have total 22 different type of crops in my data set, that you can see here. Okay, now I will ask, okay, to give me the label. Okay, data label, I will go to that column and I will ask to count the values. It means rice how many times repeated, like how many samples that you are collecting that relate to rice. So here the data is very well balanced. So here for every crop there are 100 records. So then I am going to create a pivot table. Pivot table nothing but it's just like a data frame itself, data frame. Okay, so here what I am asking is just give me the label, okay, whatever the label is there, and mean of all the things. Okay, apple, to the apple what is the mean k value? Mean k value is 199. For banana, what should be the mean k value? What is the mean k value from the data set? 50. Okay, like that. Here you can analyze this part, I think. And then I am going to check data.columns, again the same stuff. Now I am going to analyze my data by plotting the graphs, that is visual analyzing. So first what I will do is I will plot n. So when I plot the n using box plot, what this box plot will give? So it will give us the line. You can see in the center is median. It means this is the mean of that column. If I go to k, okay, here it is n, okay, if I go to that n column and if I see the values, median value is 37. It means the normal value, okay, which is 37 from that column. And again, what is the max? At max there is 140 and minimum 0. But from Q1 to Q3 many data are lying between Q1 and Q3. That means the data mainly lies between 21 and 84.5. But if you may heard about outliers, what is the outlier? Outlier is actually the data which is behind these things, behind max and minimum. So that is entirely different value. For example, if this is my n value which ranges from 0 to 140, if there is any value which says 1000 is not really a number which is suited to any agriculture farm, okay, that means that is an outlier. It should stay between 0 to 140. That is the range actually. If it's 200, that means that is an outlier. Having outlier is a problem, okay, that is unrelated data, that's unwanted data. We should handle those outliers. That we will going to do in below. Okay, here I am doing with the box plot. In the same time I am just plotting all the points. Okay, you can do using plotly that stuff. Okay, if you give points equal to all, you will get the same data in dots. Okay, the same thing you can see here. So here you can see outliers very easily. P is 120 to 143 is outlier. Actually it should stay between here and here. Okay, here and here, whatever the things comes out of this, that is 128, we call that as an outlier. So here I am plotting that using box plot and I am analyzing that stuff, so I can see very easily the outlier. Here you can see outlier very nice. So for k, this is outlier from 196 or 195 to 204. That they are outliers. Okay, they are out of bound. If we have that in our data set, it will disturb our result. Okay, we need to handle them. How we will handle them, let us see. Okay, for temperature also you can see there are some outliers. Here you can see for humidity. Okay, for humidity there are no much outliers. Okay, so we are continuing with it. And for pH there are few outliers. For rainfall there is much outliers. Okay, this is outlier data. Whatever that comes above this max, we call them as the outliers. Okay, or that upper fence. Okay, we call it upper fence or minimum max. So above this, whatever the things comes above upper fence, they are outliers. So now there are some rules to calculate this these outliers. Okay, this is visual. Whatever we saw till now is visual, but there is a technique called IQR. Using that we can find out the outliers. Okay, here what I am going to do is, here I am doing it for only rainfall. Okay, you can do it for all other features also. Okay, here I am taking only rainfall to show that how we do the outliers thing. Now using NumPy, I will be considering percentile. So it will give me what is 25% of data, what is 75% of data contains. If there is something which is you can see here Q3 plus 1.5 of IQR, more than that is outlier. Okay, what is that IQR? Nothing but Q3 minus Q1. Q3 nothing but 75% of data. Here you can see the above is 75%, below is 25%. Okay, what is the difference between them? We will call it as an IQR. Once we take that value and multiply it 1.5 and sum it with Q3. Okay, to be graphically this one, it will be value of upper fence. Okay, that calculation will give me this line. Okay, this line. So whatever things comes above this and below this lower fence, the lower fence is also there is equation. We just need to minus that 1.5 times IQR. So whatever the things comes above upper fence and below lower fence is our outlier. So we will remove those values of those rows which contains rainfall values above upper and below lower thing. Okay. So when we remove those rows, I will be having 2101 rows with 8 columns. So here I done it only for one feature, that is rainfall. You need to do it for rainfall I did because this is having so many outlier values. You can do this for pH, you can do this for what is that having outliers, okay, this one temperature, and most you need to do it for K. You don't miss it for K. The same code, use it for different columns again, okay, that will be reduced, the number of rows will be deleted which are having outliers. So once I got to know and I remove the outliers, my data is well pre-processed. But I am going to plot some graphs and to analyze the data. Here I am plotting n values with x label. It means I just want to know for rice what is the n value, for maize what is the n value, like that. I am just plotting the bar graph to visualize it. So here again what I am going to do is I am going to plot bar plot with n and y. Okay, this I am doing using Plotly, that you can see here. Again I am doing for p and label, and the same thing I am doing with k and label. So till here whatever we did, we just try to analyze our data graphically and visually, and also we removed the outlier stuff. Now we need to check correlation. What is meant by correlation? So let me give you how it's being calculated. Okay, for that I will show equation from Google itself. This is that correlation. If I have x and y values, if you apply this, okay, then you will get correlation. It is okay, this is the equation, don't worry about the equation how much, okay. This will give us what is the relation, okay, what is the relation between x and y. For example, say x is nitrogen, so y and x, okay, say y is nitrogen and our x is say rainfall. If I plot the graph, if it gives like this, okay, that means x equal to y equal to x. It means they are very positively correlated. So you will be getting correlation value 1. Okay, if my graph is like this, I will get correlation value -1, negatively correlated. Okay, this is the thing. If my line goes like this, it means it's independent of x. It don't care, okay, whatever the x, the y stays like this, it means my correlation is 0. Okay, these are the values, how our one variable is getting affected due to another variable. That is the thing. Now you can see here, that is what it will give me. What if n, what is the relation between n and the humidity? It says 18% correlated. It means if the humidity is more, then there is 18% possibility that having n in the soil will be more. If there is n in the soil particular, there is 9% possibility that pH is affecting positively. If you increase n, the pH value will be getting increased. So again you should check like this, okay, the interrelation between all the variables one by one. So the same stuff I am going to plot it, okay, using Matplotlib I am going to plot it. We call this as a heat map, okay, correlation heat map. So the same stuff whatever we saw above in this plot, the same stuff we will plot and we will make it colorized, okay, with a scale beside it. Then we need to check what are the input, like this is the feature selection step. Here we will say whatever the columns are there except label are my input, my label is my output, that I need to train, that I need to use to train our machine learning model. So before that I need to split my data set into train and test. For that what I am going to do is I am going to take 30% for testing and 70% for training. So this is my x and y are my data, like x contains all the input feature, y contains my output feature. So once I get that, here from here whatever the things I am going to do, that is building the machine learning model. First I am using light BGM model and I am going to train using x train, that is training input and training output. I will feed to that model and I will train it. Okay, so once I train it, I will push my test data as an input and I will check what is the accuracy by plotting out accuracy score. So it says 98% accurate is predicting my testing data. So in the same manner Okay, whatever I will get this function, no. So now I will try to plot confusion matrix. What is the importance of confusion matrix and why is it so important to plot when it comes to classification models? That confusion matrix will be having 4 parts: true positive, true negative, false positive, false negative. So based on these features there are so many equations. Okay, so we'll feed this data to those equations, recall score, f1 score, and like that. Okay, so all these are set of equations which are decided based on the confusion matrix. In depth about confusion matrix, if you want, let me know in the comments. I will make separate video on that. Okay, how and what are these things will show us. Okay, 29, 37, 33. I'll just give a small glimpse how to analyze this. Okay, so here you can see this is a predicted label, this is an actual label. Okay, now how you need to decide is where 0 and 0 meets, it's 29. Okay, that's fine. And now where 1 and 1 meets, it's 37. But when you see this part, let me tell you. Okay, this 2 meets, here we'll say when 8 meets 20, it's 5 year, year 31 year. What this means is, for example, the actual label is 8. 8 nothing but there are 31 values. Okay, you gave, while testing you gave 31 soil samples and the machine learning model predicted 39. Okay, from 39 machine learning model predicted 39 properly. Okay, you should grow this particular crop, but for 5 values it predicted wrongly. It said like for 31 it said okay, you need to grow rice. Okay, that's proper, but for 5 values it told you to grow maize. That is wrong. That means our model is making some errors here. So that is how you need to analyze the confusion matrix. So based on the confusion matrix only, the below things will be calculated. Okay, here I am using some scalar functions, but the reality is these are all calculated based on the confusion matrix in the back end. So here you need to first you need to check like accuracy is the main parameter. Okay, accuracy is almost equal to the recall precision score like stuff. Okay, almost precision and accuracy are calculated in the same manner. They are not exactly same, but almost they are very same. Okay, now I am going with the decision tree classifier and I am training that model, and I am going to test with my testing data set, and I am going to check the accuracy. Again I am going to create confusion matrix plot. So again I am going to take out the classification report. The same thing I will do for multiple models, logistic regression. Okay, and then okay, once I am done with all of them, I will take the best model. When we saw the above values, the accuracy of classifier model is very well, 98% or like that, more than 98%. So I am going to take that model and I am going to give my input. Okay, this is the input. Okay, n is 36, p is 125, 196, like this. These values I will feed to that model and I will get result predicted by that model. Once I get the prediction out of that, I will compare with the real values, that is testing output. So I will compare that. Okay, prediction is grapes and the real value is grapes. So the both things are same. In that case we can say our model is working 100% properly. You can do it with any other values of test data set, or you can give manually. You can give input of n, p, k, temperature, humidity, pH and rainfall separately, so that you can feed to this model and you can get the result and you can analyze how properly your model is getting predicted. So this was all about today's video. We'll see you in next class. Thank you very much, and don't forget to subscribe and like. Thank you very much.